So before we start talking about bonding and talking about structure, it pays to have a quick look at the different types of element one can find. In very simplistic terms, you can classify pretty much all the elements on the periodic table as either a metal or a non-metal. Now, what does that actually mean? Well, if we think about metals and non-metals, we group them together as these things because they have similar properties, because they have similar tendencies. If we take metallic elements to begin with, we can see that they are generally found on the left hand side of the periodic table. Why is that? Well, metals generally, although this isn't true when they get really big, but generally have less than half filled outer shells of electrons. What do we mean by that? Well, for example, aluminium has an atomic number of 13, meaning that it's got 13 protons, and as a neutral atom that means it will have 13 electrons. Those 13, two of which can fit in the first shell, 8 in the second shell, and 3 in the third shell. 3 being less than 4, 4 being half of the complete shell. So less than a half filled outer shell. What does this mean in terms of their tendencies? This means that it is energetically favourable to lose electrons to become, and this is where we just have a little trick, where to become cations. And I know I've missed out a letter, but that's absolutely fine because I'm going to put the T in like a big plus. Electrons being negative, if we lose negative things, we end up being positive because we end up with more positive remaining in the species. So, metals, they're found on the left-hand side of the periodic table. Because they're found on the left-hand side of the periodic table, or the reason they're found on the left-hand side of the periodic table is they generally have a less than half-filled outer shell of electrons, as we demonstrated with aluminium, which means energetically it is favourable for them to lose electrons, thus becoming cations. Metals tend to lose electrons. That is why they are metals. So as you might expect, non-metals, generally the opposite. Okay? They are generally found on the right-hand side of the periodic table. They generally have outer shells of electrons that are more than half full. Having outer shells that are more than half full, generally, it is energetically more favourable for them to gain electrons rather than to lose. If you think about it, if you have an outer shell that is more than half full, you will be gaining less electrons than you will be losing to get up to that full outer shell. But it is not about a full outer shell, it is about what is energetically favourable. Now, there are two ways we can gain electrons as non-metals. They can form, let's just change pen here because I did last time. They can form anions, which are negative ions. Remember, cations over here are positive ions, and you can remember that by the fact that the T looks like a big plus in cations. And If you wish, you can remember anions as a negative ion. So, just to recap there, energetically favourable to gain electrons. They can do this by straight up gaining electrons and forming anions, or as we will see later, by sharing pairs of electrons in a covalent bond, or in multiple covalent bonds. So there you go. Types of element. There are two. Why? Because metals, it is energetically favourable to lose electrons. Non-metals, it is energetically favourable to gain electrons. And that is why metals are metals and non-metals are non-metals. As with all these things, it is probably now a good idea if you go away and make your own notes on this to help you remember and understand what we have talked about.